Hopefully we will have better.
I'm gonna laugh so hard if something goes wrong.
Hopefully we won't. Yesterday, but we're live.
Cut it out?
Oh yeah, I cut it out. Like 10 minutes.
Did
Learning
you
targets.
save the cutouts?
No. Students will be able to identify and perform dilations. So far, every transformation that we have talked about. Do you guys remember? I should have put it in here. Dang it! The umbrella slide. The cool umbrella slide.
Something already went wrong.
You are going to lose your head if it's not attached to your shoulders.
Oh my god.
Yeah, everyone. The umbrella slide. We had transformations. That was what we were looking at. Different things that we're doing to shapes. What were the first 3 transformations that we've looked at so far? So help me, Layla. We'll have a phone stacked up there so quick. What are the first 3 transformations that we have looked at?
Rotation, reflection, and
Layla's attitude.
something else.
What's the other one? Rotation, reflection, translation. Nice
Layla's
job. Those are our 3
Hey,
transformations, the way that we've moved shapes.
which one
What did
was
we talk about yesterday with those 3 transformations? They all are what?
part of the solar system the same?
Congruent. Yep. After those transformations, we call them congruent transformations. Pretty straightforward there. Now we're looking at dilations. So remember we talked about rigid motions where the size, the angle measure, and the side lengths, there we go, don't change. With the first 3, well, now we're going to change the side lengths. So we no longer are dealing with the rigid motion. The angle measure will stay the same, but the side lengths will change. And then we have some real world problems for our secondary target. Order of operations, very short. We have some terms. I have, 1 or 2 examples, I can't remember. 2 examples and then 2 practice problems for you to do. We actually are going to do those today, hopefully. No mess ups. Yeah, but you still need to show me that, like, we're ready for work time, you know? If you have no idea what you're doing after the lesson, and work time's not going to help.
Sure.
What?
I'm sure it will.
A dilation. So here's our term. A dilation is a transformation, so still under our umbrella, in which a figure is enlarged or reduced.
Do I have to write that?
The definition of a dilation? No. We'll get to know. We should know what a dilation is already. With
Didn't I write
respect
that
to a
already?
fixed point called the center of dilation. And a scale factor, K, which is the ratio of lengths corresponding to the size of blah, blah, blah.
Isn't
So,
that-
a dilation. We're
Oh, yeah,
changing in size.
Oh.
So we're starting with this blue triangle, and then we are changing in size. We're dilating. This would be an enlargement because it's getting larger. Enlargement to P prime, Q prime, and R prime. That's what a dilation is. We change in size. Now we have the center of dilation, which is kind of the point that we're dilating from, which would be C. Probably terms that we want to get down here would be center of, we probably want to sketch this picture, get center of dilation and scale factor down. And I'll give you, for scale factor, I'll talk about the formula that we use to find our scale factor. So, yes, Haley?
Does it have to go in like a specific spot, like when they enlarge it?
Does what have to go in a specific spot?
Like, so you have a small triangle, and then they enlarge the triangle to be bigger, but why did they put it where they did?
We'll talk about that. Usually there'll be coordinates on a plane, so then you'll make adjustments to those coordinates. So it'll tell you right where it is. Good question. The slides are on Canvas too, if you want to see them.
No.
So draw that picture, and we're going to talk about the center dilation is point C, so you can label that. But I'm going to talk about a scale factor a little bit. So you don't need to write down the whole sentence of scale factor. I'll tell you exactly what you want to write down for that. Sketch that picture best you can. Are you trying to go until somebody does yell at you? Is that your goal, Taylor?
Maybe.
So how's it going? 50 cents.
What?
Yeah, never mind.
You think I'm giving you guys 50 cents?
Yes.
I'm bringing you a wrong jar.
What about a quarter?
No, it has
Okay,
to be
25
50
cents. Take it or
See,
leave
what
it.
would have been funny there, Kaylee, if you had said, what about 2 quarters? That would have been funny. Or what about 10 dimes? 5 dimes.
Math,
5
math,
dimes. Math.
math. You're the math teacher. How did you? You know what?
Okay, so let's look at a couple of these notes on the side. Mainly, I want you to make sure we have this down
What?
right here. So our scale factor, they use the variable k to represent our scale factor. And scale factor will equal, so k equals the length of c to p prime over top the length of c to point p, for example. Another way to think about that, saying the same thing, but another way to think about that is that k equals the image length. Now as a reminder, which one is the image, the blue or the red?
The original?
What you
No, it's the red one.
The original?
Red one.
The red one would be our image,
Yeah, who's right?
because those are the primes, right? The blue would be our pre-image,
Just say original.
or the original.
That's what we were asking.
I was asking if it's original and
But we need to know those terms, image and pre-image, because they'll use those a lot in questions.
It's the original and new.
So, k can also equal the image length over the actual length, or original length. And you'll see where that comes out. One other note that I want to point out is, and I said this earlier, but I just want to say it one more time, that angle measures are preserved. So this angle R right here is the same measure as R prime. Right over here. So that's probably something important to write down. All of these other points are fine, but we don't need to talk a lot about those. The big thing is having these two. They say the same thing, but just in a little bit of a different way. Those two formulas combine or find our scale factor. Questions on that? Layla, do you need another second, or are you good?
What?
You're good.
I took a picture.
So, this is something important to write down as well. When the scale factor, so k, when it is greater than 1, then the dilation is an enlargement. So if the scale factor is larger than 1, then we'll go from a smaller image to a larger image. When the scale factor is less than 1, or between 0 and 1, the dilation is a reduction. So then we go from a larger image to a smaller. Now, really, this should be talking about the absolute value of k, because we will have a negative scale factor. And that negative scale factor, if it's like -6, our image is still getting larger. So there probably should be absolute value signs around this k. So you'll see those words a lot. The last question, is this an enlargement or a reduction? Just talking about, is our image larger or smaller than our find the scale factor of the dilation. Awesome. Then tell whether the dilation is a reduction or enlargement. So if we look at part A first, we need to find the scale factor. Remember, K equals the length from our the center of dilation. I'm going to say center of rotation. Center of dilation to our image will be 12 over the center of dilation to our pre-image. That'll give us 12 over 8. Now, the thing with these, when we punch these into big ideas or into Canvas or whatever, or on the answer sheet, they are going to be in simplest form. Our fractions will always be in simplest form. We need to make sure we're able to use those. And what do we think? Would this be a reduction or an enlargement? Why?
B prime is clearly the one that's slightly bigger.
Well, that's true. Both of you are correct. Good. Because the E prime paperclip is way bigger than the other one, and because our scale factor is greater than 1.
So do we have to find the scale factor every time, or can we just say one picture straight for the other?
So the directions told us to find the scale factor. So it's a two-part question.
Yeah.
The second one. Our scale factor equals from C to P prime over 30. This. We have a reduction or an enlargement. Reduction.
Yeah.
Because remember, we're going from our center of dilation to P prime, to our image. So we put 18 on top, that's from our center of dilation to our image. And then we want our center of dilation to our pre-image on the bottom. So we started with P, and then we shrunk it down to P prime. So you've got to pay attention to which one is P, which one is P prime. So we're our pre-image. It's not just bigger number on top, or bigger number on top, smaller on bottom. You've got to look at what they're representing. Thank you. So now we'll take the same idea and we'll put it into the coordinate plane. So the rule is coordinate rule for a dilation. If we have a point xy, if that point is the pre-image, then this image after dilation, if it's centered at the origin, it's not will be at 0, 0. With the scale factor of k, then our point becomes k times x, k times y. So what that means, we have a scale factor, and in order to find our P prime, we would take the scale factor times the x, and that scale factor times the y. So in this example, ABC, graph ABC with the vertices 2, 1, and 4, 1, and 4, -1. And now it says to apply the scale factor of 2, so that means A prime would be 2 times 2 is 4, 2 times 1, G prime would be 2 times 4 is 8, 2 times 1 is 2. We all know where I'm getting that 2 from. I say 2 times this, 2 times that. It's the scale factor of 2. And then C prime would be 2 times 4 is 8. And our scale factor of 2 times -1 is -2. So for graphing our new image, so our scale factor, our K,
Why are the lines so close together?
equals 2. Which line?
On the x-axis.
On the x, because we have
and there's like 3 on the other
I
one.
know, because we have to go all the way up to 8 on the X, and we only have to go to 2 1.
Okay, so then the X is the coordinates, right?
You said the X is the coordinates.
Coordinates.
They're all coordinates.
Yes, okay.
You will learn
I
first.
should write that down. If I remember it.
What do you mean? What, Caleb?
K is the scale factor, and
Yep.
then X is the coordinates.
Yep. For some reason, we've been having coordinates be A and B. Now they're switching us back to X and Y. So I don't know. I do not understand why they would do that to us. They are.
I'm done thinking about brain.
That's alright.
Not gonna lie. I was really confused for a second.
She's like, wait a minute, what? Gotta be honest, I don't even remember what we were just talking about right now. Me?
He's gonna be so mad.
Just look at her chest like. I meant like the conversation we were just having, not what he was teaching.
Do we see this dilation? Do we see how that works?
Yeah.
What questions do we have on that?
I have my 50 cents.
Anastasia, have any questions? Here's your practice. So this time we have a scale factor of -2. So we're multiplying each of these by -2. And then number 2 is a little bit more tricky. So read carefully. Look at your definition of a scale factor.
What's a photo sticker?
So we kind of need a graph, huh?
You can just, you can use graph paper, or you can just solve it on, or draw. Whoa.
What's a photo sticker?
Photo sticker.
A photo
I don't know. You take a photo and then you send it to Walgreens, and they make it into a sticker.
They make stickers?
Probably.
They make stickers?
Walgreens.
Stop the timer?
Walgreens does everything.